video, I will continue discuss about the 2020 Max T Sem 2 paper part 3. In previous two videos, I already discussed about question 1 up to question 6. So in this video, I will discuss about section B, question 7 and question number 8. Question 7, given the curve y equals to ex cos 2x, where x is in between 0 up to pi. A, first we need to find the x-intercept and y-intercept. B, determine the extremum points and their nature. C, find the point of inflection. D, sketch the curve. So we know that sub-question ABC is serving the question number D. What we do eventually is to obtain the D. Okay, is to obtain D. First, at x-intercept, we know that x-intercept means y equals to 0. Y-intercept means x equals to 0. So A is actually can solve. You substitute y equals to 0, obtain your x. Substitute x equals to 0, obtain your y. You get those 2 points you need. So we know that actually later in our D, we will have x equals to pi over 4 when y equals to 0. And we will have y equals to 1 when x equals to 0. So bear in mind. B, differentiate. Why we need to differentiate? In order to find out the extremum points, we will actually need to let dy dx equals to 0. So we will know that at dy dx equals to 0, there is a maximum point or there is a minimum point, and we need to find out the nature. How to find out the nature? We need to differentiate twice, means that d2y dx squared. C, find the point of inflection. At the point of inflection, which is the point d2y dx squared equals to 0. So bear in mind, we found extremum points dy dx equals to 0. We use the multiplication rule of the derivations. We'll actually get back this term, let it be 0. Finally, we found out at this extremum point, this is our extremum point, bear in mind. This is our extremum point. But what is the nature of our extremum point? Is it the maximum or is it the minimum? We don't know. We have this point, but we do know it is maximum or minimum. So we need to run the second derivative test. In our second derivative test, we will differentiate twice again. We will differentiate twice these terms. Finally, we will obtain our d2y dx squared is equals to these terms. And we let dy dx equals to 0. Why we let dy dx equals to 0? Because we are actually examining the extremum point. And at the extremum point, dy dx is equals to 0. Substitute x equals to extremum point, y equals to extremum point, our coordinates inside, we can obtain these terms. And we know our d2y dx squared is smaller than 0, which means this point is actually a local maximum point. If our d2y dx squared is greater than 0, it means it is a local minimum point. Regarding the terms of a global and local, I would say that if inside the range, a certain range, that point is a maximum or a minimum point, we can clearly say that it should be the local maximum or it should be the local minimum. But inside an infinity range, inside the whole range of the curve that exists, or I will not say range, I will say inside the domain which the range exists, which the curve exists, the most highest point is our global maximum. The most lowest point is our global minimum. Which means among all the peak, all the valleys, that is the highest, there is the lowest. So that we will call the global maximum, global minimum. The small peak, small valley within a certain range, we will call it as local maximum, local minimum. Okay. C, find the point of inflection. Let d2y dx squared equals to 0. We use back the equation we obtain in our B. Use back, substitute here with 0. Then we obtain this equation. So my range is, if my range is 0 up to 2 pi, I will actually get this formula. X equals tangent inverse negative 3 over 4 divided by 2 plus pi n divided by 2. Because these are the repetitive cycle, n is the number of cycle. Why this term will occur? Because we know that in cos 2x, cos is a repetitive curve. We know that when this one is a y, this one is a x. If I have a cos x, I will actually obtain this thing. If I have a cos x, I will use the cos x. I will actually have this thing from 0 up to 2 pi. I will call that this is a one cycle. Cos nx, where this is when n equals to 1. This is my first cycle. in the second cycle, it will repeat the same thing. Third cycle, fourth cycle. So we need to justify. Which is, what is our n? But since we are given our range is between pi and 0, so we don't need to bother about this thing. So remember, always check back the range given by the question, because it is for mathematically correct. You must strengthen your concept about the terms mathematically correct, because it will make your solution complete, and it determines whether the examiners knows whether you master the mathematically concept correctly. So we cross out this point, because n equals to 0. N cannot be the floating point. N can only be the integer. So when n equals to 0, then we substitute all these terms inside. We will actually get back x equals to negative 0.64350 over 2. This is our x. And then we substitute back this point back to here. We can obtain our y. Okay? So this is our point of inflection. Finally, we need to plot out our curve. So as I mentioned just now, mark out our x-intercept 1 and pi over 4. So this is 1, and this is pi over 4. This thing I didn't mark up it until which pi n over 2. I didn't mark up. This can be n equals to 1, n equals to 2, n equals to 3, and repetitively n approaches to infinite. So you will have this type of curve. And when we examine back our point of inflection, we will actually obtain this thing. Can you see that at here? So always check your D, because D needs ABC to serve it. Question number 8. The curve 9y squared equals to 10x and 4x squared plus 9y squared equals to 36 has an intersection point P in the first quadrant. First quadrant means that y is greater than 0, x is greater than 0. That means the first quadrant. We'll consider that as a first quadrant. A. Find the coordinates of P and hence sketch the curves on the same coordinate axis in the first quadrant. Usually x equals to x greater than 0, y greater than 0. This is the first quadrant. B. Calculate the area of a region bounded by the curves and the y-axis. So when this question shows up, we know this is an integration problem in our chapter integrations. C. Find the volume of a solid generated with the region bounded by the curves and the y-axis. Is revolved completely about the x-axis. I guess is completely revolved about the y-axis. I think this part I accidentally moved it downside. Is revolved completely about the y-axis, because I look back the curve I sketched. Okay, so let us dissect this question. First, we know that at 9y squared equals to 10x is actually the quadratic curve, because the y squared occurs. Quadratic curve on where? Based on y-axis. Because we know that x squared, if we have the y equals to x squared, we will actually have this thing. Looks familiar, is it? This is a quadratic functions where y equals to x squared. Same thing. X equals to y squared. You will have this thing inverse on the y-axis, which only exists at here. If you multiply a constant here, if a constant is greater than 1, it will make your curve steeper. What I mentioned about steeper, it means the gradient will be more steep. It will not be flattened. Okay, so this thing done. If we have the formula 4x squared plus 9y squared equals to 36, okay, this formula, it means that I'm dealing with an ellipsoid. Okay, I'm dealing with an ellipsoid, because you know that the ax squared plus by squared equals to r squared. This is a formula of a circle. So when dealing with an ellipsoid, I will actually have my b is 9, my a is 4. So I will have this thing. I will have this ellipsoid. Bear in mind. After that, if I only taken the first quadrant, where x greater than 0, y greater than 0, I will find out this is the thing it will shows up. And these two terms, we need to find their intersections point. We need to find their intersections point. How do we obtain this intersections point? We can find the common terms between them, and to find the intersections point between them. Okay, so we move the in common terms all to our right hand side, and we equate them, where we can obtain the x, we can obtain the y, the coordinates of here. Okay, the coordinates of here. After that, we need to find the area region bounded by the curves and the y-axis. Bounded by the curves and the y-axis. Bounded by the curves and the y-axis. So in this case, which method you think is easier for us to find the area? Is we integrate on the x-axis in terms of dx, or we integrate in terms of dy? Actually, both methods are acceptable, as long as you can get the answer. Yeah, both methods are acceptable in this case. In this case, I will actually prefer to use dy. I will actually prefer to use dy. Why I will use dy? Because I already have my limit. This one of their y-intercept, I already have a limit, and this thing, their y-intercept, and I obtain this intersection point. I obtain the y value here, which is my b, my ABC. I already have these three limits on my hands, so I will choose to find the area by integration based on y-axis, which is in terms of dy. It's convenient for my side. If you want to use dx, also can. You need to find out this limit, and use the red curve minus the blue curve. Okay, use the red curve minus the blue curve in between x equals to 0 and x here. This is also acceptable. So depends on personal interest. Okay, I will use in terms of dy. So after I've integrate these terms, I will actually need to sum out this from this area, from limit a to b. I sum out this area, the blue curve, minus x equals to 0. Blue curve minus x equals to 0. Red curve minus x equals to 0. So from a to b, b to c, I will separate into two areas. When I separate into two areas, I need to split it into these additional rules of integrations. And I integrate these terms. I need to find the terms in terms of y. We know that commonly we will assume y equals to fx. But when we do the integration in terms of dy, we need to reverse the whole thing. X is actually equals to fy. So these two terms are actually interchangeable. It depends on how well you know about the mathematics, about the functions in your last terms. So when I change in terms of y, can you see, in terms of y, and I integrate, this representations is actually my x. This is also my x. I integrate them. See, I integrate them, and I obtain this answer. Okay, so about the limits, you must change the limit, just like I mentioned in the past two videos, because the limit must on the y-axis. Please take note, the limit must on the y-axis. Don't miss out with your x-axis. This is the most frequent mistake the students will get. So how do I integrate this term? 9 minus 9 over 4y squared, such of this thing. I will get square root of this thing, and I need to use the substitution. Where y equals to 2 sine theta. And after that, I will obtain integration of 4 cos square theta d theta. And again, I use the trigonometry properties to solve. When I use the trigonometry properties, I can split it into these two terms. And finally, I substitute back my y inside, I substitute back my y inside, and substitute back my limits inside, I will obtain this answer and this answer. So that's how I solve the question number 2. If you think this thing is very complicated, you cannot use this method. You can actually integrate on the x-axis. That's also acceptable. But here I perform the integration on y-axis is to provide another view on how to solve this solution. So see, the volume of a solid in this question, it says that it revolves completely about the y-axis, which means this thing it revolves about 360 degrees on the y-axis. So it's something like something like this one, a curved cone, upside down curved cone. Okay, so what we know that is we need to sum out two solids together. Y is the two solids here. When we look back, in this curved cone, we have a hemisphere. From limit B to C. There is a hemisphere on the upper part. Whereas in the lower part is the curved cone. We have the limit from A to B. So that's why I split it into two solids and plus them together. Okay, I plus them together. So there is a two solids, and I need to use these properties. Volume in terms of y is equals to pi integrate b from a to b x squared dy. So this is the volume formula of integrations, and I plus these two volume together. I will obtain volume is equals to 7.10214. Okay, so that's a basic idea. I use two volumes. If some of you maybe say, if I want to use rotation, if I want to use x-axis, how am I going to solve these questions? If you use the x-axis, it will be hard for you to solve these equations because all of your limits is stick on the y-axis. So it's very hard to solve using the x-axis. For C, it doesn't so flexible like question B. You can use dx, you can use dy. No, in question C is another story. So I believe the integration of these terms is very easy. Is the basic of integration. So I don't need to demo it here. So finally you will obtain these terms. Thank you.